Hello, in this video I will show how to use a simulated OpenPlanner rather than the ego vehicle, actually to test the vehicle, to simulate it as a lead car that the ego vehicle will follow. It's a bit tricky to set up this. You can do it actually not only with CARLA, you can do it with normal RVs or a real car. So let's get to it. There is some files we need to edit. First we need to edit the val and say we want to use this simulated car, which means we need to disable enable object insert. This, as we saw in the previous video, only enable us to insert using RVs, insert an obstacle in front of the vehicle or anywhere in the map. So if we say false, now this is enabled, enable OpenPlanner simulation. Then when we do that, and save, we need to go and check the local planner launch file. In the local planner launch file, we launch trajectory generator, motion predictor, and trajectory evaluator, and of course behavior selector. And we have here the enable. We check on the enable OpenPlanner simulator, and if we are not enabling object insert, then this is called. The car simulator runs OpenPlanner, another copy of OpenPlanner. So if you understand the parameter for the local planning, the OP common params, it's exactly here the same. Only difference with additional minor changes like what color do you want and where do you want to log the logs for the simulated vehicle. And also here, if you want to enable looper, then this simulated vehicle, when it reached the goal, it will start again from the starting point over and over. Here, this is the tricky part. When we select the start and goal position for the simulated vehicle from our viz, we need to enable this parameter. And once we selected start and goal and turn off this node, it writes in the simulator's logs the start and goal position. Then we need to come back and set this to false. Then every time we run this simulated vehicle, it uses the same previous selected start and goal points. Of course, if you know the points already, you can go to the file in the log folder and set the values x, y, z for start and end by yourself. Also, we have here a maximum velocity, which we want. Of course, we want it to run slower than the ego vehicle to see the effect of following behavior. Okay, now it's default set. You can check later each parameter. Also, you can enable object detection and following for the simulated vehicle itself. One important thing is it depends on the vector map or KML map as all OpenPlanner functionality. So we have to give this, we say we use KML and the same KML map for town 1. So everything set. We need only to enable this true. So we select for start and goal point for the simulated vehicle. Let's start. Okay, uh, our ego vehicle start from here. I would start the simulated vehicle before here, and the goal will be at the end here. If you can see that there is a TF for this simulated vehicle at this point. So let's turn off this and start again. Of course I didn't set I actually didn't enable again the visualization. We can see here the ego vehicle try to follow, but localization initially were not accurate. So at the initial setting we don't need to do this. Let's start again. And change this variable from true to false. Save and start again. Once we start, we can see here is this is the simulated vehicle, and this is ego vehicle. We need to set global path. Actually, we don't have a global path for the ego vehicle yet, so we just select goal position, maybe here, then we start following. As we can see, it's in the follow mode. Slow down before the vehicle, and because this is really slow, it stop and stop and go. This is actually, yeah, we can see here the effect of this. As we see in our video for the PID parameter, the current PID are not tuned for smoothing, for a smooth ride, so it's actually try to reach the target velocity as fast as possible. That's why it's stop and go, and the target velocity for the lead vehicle is around 11 km per hour. It's really slow. So for faster, it should follow smoothly behind the lead vehicle. We can see here it reached its target point, and the ego vehicle is waiting behind the lead vehicle. With this we can test and tune the follow parameters, and follow parameters dependent on the acceleration PID. So for the high control, if we go to the high level controller here, the follow PID is dependent on the acceleration PID. It is 0.5 of each value. So once we tune this, the follow PID will of course will follow the same behavior as this PID. Or if you want to separate parameters, you can add it. The source is you can read the source code, and you can separate the parameters from the gains separately from acceleration and follow PID. And that's how we create a simulated vehicle and follow it using virtually on the simulator. As I said, if this is a real vehicle, it will stop without a reason, but the reason is we have fake leading vehicle. We don't have to risk and use unsafe vehicles or objects to test the planning functionality. With this, I end this tutorial. Thank you very much. And of course, if you have any questions, please ask anytime. Thank you and see you.